Okay, why don't we go ahead and get started? Good morning, everyone. Thank you so much for joining us today. My name is Taryn, and it is my pleasure to welcome you to our second ever virtual event in partnership with DDN. We have an exciting and informative session for you today. Our focus is on optimizing data for your AI stack. We will have a live demo of deploying Llama 3 on our own GMI Cloud's platform. Today, we also have 3 guest speakers. Before we dive in, just a couple of reminders. Please feel free to use the Q&A function to express your thoughts and questions throughout this presentation. Click the activity button in the bottom right corner to access the Q&A function. We will have a dedicated session on the last 10 minutes of the presentation allocated for any thoughts and questions from the viewers. This session is also being recorded and will be available for replay on our LinkedIn, Twitter, and YouTube channels. Now, I would like to pass it over to Shane for a brief introduction on GMI Cloud before we dive in with DDN.
Sure. Well, first of all, welcome to everybody who's joining today to learn more about our subject matter, and then also more about DDN, personally one of our favorite storage providers in the world. But first, we want to introduce, GMI Cloud, which was a business that wasn't even in existence 8 months ago, which is pretty crazy to think about. And we now have thousands of cards, GPU cards in production across 5 different data centers. So for us, it's been a very fast 7 months. We're proud to have also DDN in some of our data centers. So you'll learn more about them today and kind of why AI companies also choose them to be part of their AI stack. But we're venture backed. We're an NVIDIA cloud provider. We primarily today have 2 SKUs, and that would be the H100 and soon to be H200, which will be in our data centers this fall. And so we think about our world from the software stack, from a Kubernetes offering that we have to allow you to better orchestrate and connect to foundational models. You'll see a demo of this in a few minutes. But then also offering bare metal as a service as well for people who just want need their GPUs. And so that's a little bit about us, and we're excited to present to you today. Just a little bit about our platform here. I think the best way to say it is that the AI and GPU world is complex enough. So what we're trying to bring is ease of use to our clients that are out there. So for us, you'll see within our user interface today when we demo later from our choosing of DDN storage, everything is really meant to make a very complex world less complex. And those are just some of the benefits of our platform, which we'll follow up on after the call. And then the full stack platform that we have today, as I mentioned earlier, today, most providers are strictly bare metal as a service for NVIDIA GPUs. But what we did is we have one of the best software teams in the world that we hired from Google, who came over from Mineral AI, who will be demoing our platform as well. And so a lot of times data science and AI guys and gals just want their GPUs and they want to train their models. And so what we're trying to do is make that world easier by combining that platform into one. And that'll be the demo in a few minutes that you'll see. One thing we're most proud of, a few months ago, we did one of the first NIMS integrations into our platform. So today, if you want to launch a NVIDIA software NIM, it is templatized, which I'm not sure that's a real word, but it is within our platform today to where you can be able to quickly launch that, whether it's a healthcare NIM, could be life sciences. There's a lot of other ones that they have as well. And so we're incredibly proud of that. So if you wanted a demonstration of this, if you're a solid NVIDIA shop through and through, post-webinar, we're available at sales@gmicloud.ai to be able to show you what this looks like, because it's not something that a lot of shops have. And we just showed that for the first time a few weeks ago at HPE's Discover in Las Vegas. And then, as I mentioned, our data centers today, we have 2 in Taiwan, 1 in Thailand, and soon in about 2 months, we'll have a very large cluster in the United States. And so a lot of times people will say, well, why Asia? Not many people know this, that the majority of the world's NVIDIA GPUs are actually manufactured and put together in Asia. So our idea was to kind of bring the data center closer to where the manufacturing plant is. So instead of it, riding a 6-month journey back from Asia to the United States, we can get GPUs faster to our client base that's out there. And so more data centers to come. And then just a pricing perspective right here. Private cloud we consider to be bare metal as a service. We have DDN optional for clients who need something more high-speed performant for their scale out on the private cloud side. Usually averages around $250 an hour. And that all is dependent obviously on term and down payment and those. But I find most buyers are conditioned when they show up to know the questions to ask when they arrive. Our on-demand side, which is really no commit, no down payment, and just utilizing our GPUs on an on-demand basis, is around $440 an hour, a little bit under. And so it just depends on the type of environment you want. If you're doing a lot of dedicated fine tuning, which we'll talk about later, and then eventually we also offer inference, which is actually amazing from a price perspective, because when you take out the InfiniBand networking, which is usually one of the most expensive pieces in the entire puzzle, and you're just doing inference to your production users, there is ROI and value add for many reasons from there. Cool, and that's the introduction on GMI.
All right, now I'd like to pass it over to both Shane and Kurt for a fireside Q&A chat. Okay, Shane, what are some specific challenges AI developers face with data integration for inference and fine-tuning workloads on GPU cloud platforms?
It's a great question. One of those, I think one of the cardinal sins of our industry the last few years is that actually finding GPUs has been one of the greatest puzzles to solve. And so what ends up happening a lot of times is that your workloads that you're training and your models are split across many different locations. And that could be because this one had enough GPUs here and this one had some GPUs over here. And you really have to kind of sync that data up across multiple geographic locations, not even before you even get to inference, but when you're talking about fine tuning your models at that point. So when there's various changes that you need to make and how those are rolled out to all your various different sites can cause delays in data availability. One site might have the latest update that you've done in your model, the other side might not. And so then that becomes really problematic when you get into inference. So when you're actually trying to service your production users and they do not have the latest and the greatest that's there, and that leads also into data consistency. So ensuring that your data across the different environments that I talked about. So if you're doing inference in 5 or 6 different geographic locations around the world, servicing users on an app or a website through your AI model, then again that is very challenging for clients. And remember what brought in a lot of these ML and AI shops first. Enterprise is slowly coming in, but the other ones got pushed into the rental market because they didn't have these management expertise that were on their staff. And so these are some of the things that people think about daily, is that, wow, this was a lot more complex than I thought. And then finally, just the integration at that point. There's a lot of different data formats that are out there. And what starts to happen eventually is that you have to have different level of expertise and experience to come through for managing the different data formats that you have, and a lot of complexity gets driven into your environments globally.
Mm-hmm. Definitely. Thank you so much, Shane, for that. I'm going to pass it over to Kurt now. In terms of data management strategies, can you share some key strategies for managing large data sets, specifically for inference and fine-tuning on GPU cloud platforms?
Sure thing. First, I think maybe a little quick introduction to who DDN is. So we are an AI storage platform vendor that is focused on delivering really a simplified experience with high performance to folks consuming large numbers of GPUs. So just a perfect example here with GMI. We're seeing more and more of the NVIDIA cloud partners adopting us as the default storage solution for them. And there's a number of reasons why. The things that we've been solving for are very similar to a lot of the challenges that Shane's already mentioned, right? We're trying to simplify something that is indeed very complex, right? Folks are bringing in a huge amount of data, and these data sets are now quite varied. You've got all sorts of different file types. You've got object in the mix as well, and trying to figure out how to take these environments and scale them to be able to meet the needs of folks who are consuming thousands of GPUs, keeping those GPUs 100% utilized, and making sure that the data is in the right place at the right time is fundamentally the challenge that we've been addressing. And so, one of the major reasons I think I'm here today, right, is to talk about what the difference DDN makes for GMI Cloud and its users, right? So by utilizing our storage platform, customers can know that they are getting 100% of the GPU that they're paying for. One of the major challenges within an AI environment, especially folks who are doing heavy training workloads, large language models, generative AI, is that they're often doing frequent checkpointing. Checkpointing is a write-intensive part of the workflow. And so you need a storage system that really can keep up with the demands of folks needing to checkpoint their models at various points. People are doing this as frequently as on the hour right now, mainly because, again, we're in a very complex environment, very complex tools. These things are going to fail. And so we need to have protections in place to be able to roll back, not be losing progress, and being able to reduce our training times significantly. And so by being able to speed up all of the right workloads, we can actually return to customers somewhere north of 30% of the GPU time that they're consuming. And so, folks who are using a GPU cloud that's backed by DDN can know that they're getting 100% of their GPU utilization, as opposed to other storage vendors who maybe struggle with, some of the data intensity of the AI workflow. Additionally, right, we've done significant work to help folks simplify the data lifecycle management. So getting data into the cloud, returning data on-prem, archiving data, all of those things have been massively simplified to make sure folks are really realizing each part of the workflow, but at a cost point that's going to make sense, right? Mm-hmm. So that you've got high performance when you're looking at the data intensive GPU computing, but then during archival time, making sure that data is stored on storage that makes sense from a price point. So, you need to have this total package that allows you to both be computing at the most scalable and highest performance, but then also doing it at a cost-effective manner.
Mm-hmm. Thank you so much for that, Kurt. Another follow-up question, just in terms of storage optimization techniques. How important is storage optimization for AI inference and fine-tuning workloads on GPU cloud platforms?
Yeah, I think, again, I touched on a few things, but, there's a few key metrics that we are constantly chasing, right? Making sure the throughput is optimized and the data path is optimized. There's nothing in the way from the storage media all the way to the GPU. So doing so by working really tightly with the GPU vendor, NVIDIA, We've been doing so on an engineer-to-engineer level for more than 7 years. And we've really crafted the data path so that it's as efficient as possible, improving performance and reducing latency. And then I already talked about what's the benefit of that, right? That really maximizes the resources. So today I know folks are looking and comparing at the capabilities of different clouds. And where am I getting most of the performance? And what you'll find is that folks who are using DDN within their cloud vendors are finding that they are getting better GPU utilization than they are from other cloud vendors, where the data path may not be quite as optimized, or the efficiency of performance might not be as balanced for both reads and writes. And then finally, by gaining that efficiency, right, you're getting faster training time, faster inference time, faster answers, better ROI by having to, you can reduce definitely the time that it takes to make your way through the entire AI workflow.
Yeah, amazing. Thank you so much for that, Kurt. Going back to Shane on ensuring data security within AI applications, what are some unique security challenges that arise in handling data for inference and fine-tuning on GPU cloud platforms?
Yeah, security right now, if you look at the normal enterprise world today, you have CISOs and CIOs and who really think about security, are almost security first organizations. Within the AI world today, that's a little different only because people just want their GPUs. And a lot of times security isn't a first thought that they have around who's accessing it. It is their corporate data that's residing on these servers, and a lot of data is also being pushed over the wire to these locations that are out there. So some of the things that we've done as providers is to make sure that the data connections of the data centers that we choose to co-locate in, and these are all tier 3 and tier 4 data centers, have the most robust carrier hotel connections, so it's really encrypted in travel, so that when the data is going back and forth, it can't get lost. The other thing is the handover of servers. I think a lot of times when people start in this game very early as a GPU NVIDIA cloud provider, you're literally handing over SSH keys and IP addresses and like, here's the 6 servers you bought from me. And I think what you end up quickly learning is that that's where a lot of bad actors can get in play and be able to do vicious malware on the servers, and there's many other things that are out there. So we do things now where we ask clients to give us their source IPs, so we know who actually will be accessing the GPUs coming in our direction. The identification of the users who will be using the GPUs that are there daily. We also are going to have some industry-leading security partnerships that will be announced next month at Black Hat. For the first time, as you start to swim upstream and sell to more enterprises that are doing AI, they're going to give you their spreadsheet of about 100 items that you have to check through, whereas those don't really exist today when you're dealing with an ML AI seed through Series B type of persona who's buying from you there. The other thing is just around model integrity. It's safeguarding it again from tampering that's out there. The cemetery of NVIDIA cloud providers is full of stories of people who came to do brief POCs and left things that they shouldn't have left there, that ended up causing nodes to have to be rebuilt for weeks at a time, and which is obviously lost revenue, and it's lost training time for these clients that are out there. And the last thing is just compliance. We're as I mentioned earlier in the beginning of the call, we've only been in business now for about 8 months, and we're currently under audit for our SOC 2 Type 2 and ISO compliance certifications that are out there. So if you are a buyer looking for, just because you find the financing to buy the GPU boxes, you really, as a buyer, want to be asking those compliance questions that are out there and what type of certs that provider has. And that's one thing we've recently invested in and are excited. It's going to help us grow as a business as well, because the framework that these compliances really force you to have for both internal and external reasons make you a better provider. It's out there.
Definitely. So now transitioning into integrating GMI Cloud with DDN, Shane, how do you think, or how does the integration of GMI's and DDN solutions create a robust infrastructure for AI inference and fine-tuning on GPU cloud platforms?
The one thing we love about DDN is it's founded by engineers. Outside of Kurt's amazing marketing that he has at various shows and things. When we spend time with the two co-founders, I spent the most time with Paul out of the two, but they're passionate about this, and the one thing that they do is the ease of use and integration that's in our platform. So we have a very large appliance for DDN in one of our Taiwan data centers, and all a client has to do is just request for us to increase their store size, and the integration and the way that it's built and the ease of use. It's someone can say, hey, I want another 150 terabytes added to our store, and within hours one of our engineers can have that back to the client. Whereas sometimes when you're dealing with NVMe storage and some other providers that we've tried out, it's a little bit more complex, and time can be an issue at that point. So we love the unification of the platform for our clients, and also our hardware engineers who are at the data center, working on this. That's there, and also it's the speed in terms of reducing latency and overall performance. As Kurt had mentioned earlier, a lot of times these days, the reason why at NVIDIA shows, you'll have clients standing up there really talking about their DDN and NVIDIA environments and just the speed and performance that they have. And a lot of times that's time to money. And so for these clients getting their models to market, and then, not even talking about inference and production, and when you're really monetizing these models after training these things for 3 and 4 years, you want the best performance that's out there. And so that's a huge reason why we've chosen DDN across our data centers. And then finally, just scalable AI projects that are out there. It only takes someone to say, why aren't we doing this? And that this becomes a model that gets trained, and then how quickly you can be able to scale that up in an environment like we've done for some of our clients from the Bay Area to the EU to Asia. And a huge part of that has been our integration between DDN and GMI.
And if I can just touch a little bit more on that, right? I mentioned we've been working engineer to engineer with NVIDIA for 7 years, and given that they are a large part of the footprint within GMI, I think that work, right, is really passed on all the way to the end customers, right? We're working with NVIDIA on their own largest clusters in-house, right? Their Selene cluster, their EOS cluster is running DDN behind it. So we've encountered a lot of the corner cases that happen at scale, and been able to solve around those. And so now, right, really when a cloud provider chooses NVIDIA with DDN, it really already is an integrated solution. So like Shane was saying, right, you request some more space for your data. You need some high performance shared space. That's just going to work. And so as an end user, right, there's very little to next to nothing that you need to do besides that request to be able to get access to this high performance end-to-end infrastructure.
Yeah, thank you so much, both of you, for those great answers. And just to end off this fireside chat, we have a fun question for both of you. If you could have any AI-powered tool or gadget from a science fiction movie or book come to life, what would it be and why?
I've always thought that when you watch the Iron Man movies with like Jarvis and Robert Downey Jr.'s main character he plays, of just being able to have someone to kind of not just like an AI powered butler, but something that can be able to kind of help plan your day. And obviously today we ask Alexa and Siri and other things, kind of what's the weather going to be like, and those other things. But then to eventually have a situation where you see the panels in front of you without having to wear Apple set of goggles to help instruct your day, and that would be really kind of a cool, useful thing to be able to have in real life. Something to think about.
I've got a similar, I think, character, and mine is Baymax from Big Hero 6. I really like it because so often, right, AI is depicted in movies as, something that's threatening, or, often it's the humans have to battle the AI. But, I think it was, such a lovingly crafted character, with a lot of, some of the limitations that we already encounter with AI today, right? There's a bit of realism built into the character, right? Doesn't understand human emotion, is really just there to help when somebody's hurt, but also shows the potential for, more general AI as it does learn over time, that human emotion is just as important as the physical injuries to making sure someone's healed. And then, yeah, it's always helpful if they can fly around and shoot things and defeat the baddies as well. But, it just seems like, a semi-realistic illustration, especially at the beginning of, the promise of, some kind of healthcare diagnostic engine that will be able to, assist people in home, and be able to not only assist them with the physical pain, but also, provide mental health support as well in the future.
Great. All right. Both awesome answers. Thank you so much, Shane and Kurt, for the fireside chat and answering all the questions that we had for you both. I'm now going to pass it over to Eugene, who is going to do a 15-minute live demo of deploying Llama 3 on our GMI Cloud platform.
Thanks for having me.
Oh, Eugene, you are muted.
Oh, hi everyone, Eugene here. I'm gonna do a short demo regarding how we're gonna do development on our GMI Cloud. With that said, let me pull up my screen. All right. So as you can see, this is currently our on-demand service UI. On the left sidebar, you can see a bunch of stuff. For example, we can offer direct bare metal, and under each on-demand service, it's controlled by Kubernetes, so you can have access regarding the cluster it's themselves. And what's most importantly, which is the thing we're going to demo, is the container. So most of our environment are containerized, so you don't have to worry too much about getting stuff up, you don't have to worry about, for example, how to segment different GPU resources. We also offer other functionalities like managing your own SSH keys, so you can log into your containers through any platform you would like. And we also offer the ability, for example, here to manage different templates when it comes to the containerized solution. So we offer a variety of pre-built templates here. As you can tell, we support Llama, and we support NIM. We also support the fast inference library that NVIDIA provided called TensorRT, and we also have some other fun project, for example, like OpenSora here. You're also able to manage your own organization, mostly just manage your own users, add your own audit log, and some basic settings. All right, with that said, let's go back to the container page where we'll do most of the magic. So when we jump to the container page, the first thing we realize is we need to start a container. So here you can either start a container based on a pre-built template, or you can do the container using your own Docker file. So here we're going to pick one pre-built container, and then we need to pick what's the hardware type we're going to use. So here it depends on how many GPUs you have access to. For example, if we for inference or fine tune, we can choose normally we can choose 2 cards. After picking a number of GPUs, you are asked to specify, for example, what's the number of CPUs you want to use in this specific job, and how much is the RAM and firmware storage, etc. And because it's a containerized solution, you also support port forwarding. For example, if you want to match a specific port to some external port number, you can always do that here. By default, we expose the access port 22 for SSH and the 8888 for Jupyter Lab. As you can tell, all the container solution we have here support Jupyter Notebook, so it's more of an interactive user experience when it comes to containerized solution. And here is really where the DDN magic kicks in. You can specify what kind of local storage you want to pick with the GPUs, and you can also specify, for example, what's the NFS storage you want to use. Supposingly you're sharing this with, for example, other coworkers, or you want to just load a checkpoint from your previous work. You're also allowed to specify environment variables when it comes to launching a container, which is important because if you, for example, if you want to use a pre-built NIM container, you need to specify, for example, your NVIDIA key in order to make it do work. And lastly but not least, you need to add authentication SSH key by adding here. For here, I already added mine. So I'll use the SSH key I created from my laptop, and finally give it a name. Say Llama 3 demo. Then you just click launch and wait it to turn on. I have a couple containers started already here, so I'm going to just start with this fine-tune container first. So this is basically today I'm going to do 2 demos regarding, one is regarding fine-tune itself, the other is for inferencing. So let's take a look at this fine-tune demo. So as you can see, we support some basic functionality, for example, viewing the logs of your container, accessing your container directly through SSH, or accessing your container's Jupyter Notebook. So once I click here, I need to switch to this tab. So for this fine-tune, it's where we use the QLoRa in these templates. It's kind of a standard. If anyone has played with QLoRa fine-tune before, so you just need to log into your Hugging Face account, download some of the testing data set here. Because we use DDN, the downloading speed is pretty fast as well because it's mostly writing. After that, you need to use the actual fine-tune script we prepared here to fine-tune a model regarding against your own data sets. Then we merge the load and run it against a test benchmark. So I'm not actually going to run the script here because it's going to take a long time. So we will go back to see, once it's finished training, what inference would look like. All right. Okay, looks like this one is taking some time to start. You might want to I want to try again with a less resource. Sometimes there could be a problem if you don't have enough resource or something got stuck. I'll still try to do 2 cards. So you can refresh. Oh, right here we have one. So it took some time for it to initiate, but there we go. So once you log into a freshly created container, for most of the freshly created container, we will have a notebook attached to it. But for containers, for example, like NIM, it doesn't really have anything other than the name container itself, which is directly introduced by NVIDIA. So here, since we have, let me check. And for example, here you can tell you have 2 H100 GPU assigned to this container specifically, which is great. And because we have two H100, I think we can try something bolder and actually load the 70B model. Yep, the model is being loaded up. It's actually pretty fast. But if you're loading using one card, you have to use either a more aggressive quantization approach or using a smaller model, which is the 8B. All right, as we can tell, the graph capturing is finished. That means we can actually run inference here. And because we're using a interactive approach here, we can actually launch a Gradio UI within the notebook and give it a go. So what should we ask them? Tell me a joke about GPU and DDN. Let's see how good it is. See, because we have actually added the format into a system format, it will have the think process and the answer. So it's some flavor. You can customize your own LLM. I'm sure a lot of people here have done that before, but here is just showcasing how you can use our GMI Cloud's infrastructure to quickly do the fine tune and do the inference using a larger version of the Llama 3. All right, with that said, that's all the presentation and demo we've done today. I will pass the baton back to Taryn.
And I just wanted to say that I hope, Kurt, that you will use that as part of the future marketing, the joke that's in there about why did the GPU and DDN go on a date. I thought that was good.
All right, thank you so much, Eugene, for that amazing demo. I want to pass it along to the different questions that we got in the chat throughout the presentation, just for a live Q&A session with either Eugene and Kurt. So to start out with, I got a question from the audience for both Shane and Kurt, and that is, with the rise of multimodal foundational models, is there an increased importance in restarting and checkpointing?
I think so. I mean, the birth of, what the GPU does is if you can, checkpoint and restart the GPU without affecting the actual application, that's at the end of what you're training, especially if you're in inference at that point. And if you fine-tuned enough to move into inference into production, the fact that you can do that without really having to mess with the application that's kind of client and user facing, I think is a pretty cool development in the last few years. That kind of client.
Kurt, I'm not sure if you have any input on that question as well. If you wanted to kind of double back on what Shane answered.
Yeah.
I think you might be having some audio. Oh, there he is.
I think he may be having some audio issues. I do have a few questions for Kurt that I could wait to share until the end, but a question for Eugene, in terms of GMI Cloud's platform, what measures does our platform take to protect individual user data, and how safe is it for somebody to use?
That's actually a very good question, and a lot of people will ask this in the first place. So, as you can see, our thing is managed by Kubernetes, and everyone will have its isolated container. Without your own key, other people won't be able to access your own resource. That is for sure. And I'm sure DDN has a lot of other data security best practice done on their own site. So there isn't really much you need to worry about, because like first, the resources are not shared. Your storage is completely isolated from other users. So unless you're giving out your key to somebody else on purpose, your data is secure.
Great. Yeah, thank you so much, Eugene. For Shane, can you explain the biggest challenges you face as the VP of sales in a cloud provider company? And then how does this compare to the experiences of other B2B industries? And are they similar, or what are the bigger differences?
I think today, if you're looking at it from a pure, infrastructure as a service perspective, if you're, a VP of sales at AWS or other kind of traditional cloud computing companies, you have so much abundance of compute at your disposal. And I think, and also data centers that are out there that are meant for that type of environment. But within the GPU space, it's incredibly hard to really, find inventory that's out there. The ever evolving new chips that are coming out down the line that kind of force clients to figure out exactly kind of how much do they need now of the current innovation that's only probably 16 months old tops. And then also finding data center space out there for your GPUs. You're never kind of worried and thinking about selling the GPUs you have at the moment. You're thinking, do I have more coming in the next 90 days? And do I have data center space that's going to be new and ready in the next few months? So I think that's one of the biggest challenges today, particularly in this space. And then of course, just anytime you're in sales in a high pressure environment, I had a full head of hair when I started this career, and look at it now. But that's what I think is probably the most interesting part of the question.
Yeah, definitely. I guess kind of following on top of that, how has your past experiences led you to kind of the startup industry and leading the sales at a new company?
I've worked for companies that have hundreds of thousands of employees, and they have, so much process sometimes that it's hard to, be able to navigate quickly and execute. And then, here, while sometimes things seem stressful at a small startup, you can at least impact change sometimes a little quicker and be able to, kind of create new you're essentially writing the process at that point. And it's fun to see a business grow from zero revenue onto 50 plus million of revenue. And so all of that comes with people who are in the foxhole with you, working every single day with their sweat equity. So that's heartening to experience as well.
Great. Another question for Eugene is, what is the biggest challenge you face while deploying Llama 3 on our GMI Cloud platform, and what steps do you take to overcome that?
When it comes to deployment, there isn't really that hard, in my opinion. The only thing I would say most people would be facing is to actually download the checkpoint and make it work. For us, we have this thing called Model Garden, like I just showed. So if you have already agreed to, for example, the term of use of Meta, we welcome you to just use our Model Garden, so you can you don't have to download all these checkpoints you're interested at. And also, when it comes to deploying itself, you really just need to pick the right amount of GPUs that matches your model size. For example, we heard that Llama 3 405B is going to release maybe later this month, and we will surely give it a test. And for that one, maybe we need 6 H100 just to do the inference. So with GMI Cloud's GPU, I would say it's relatively easy because we use the top-notch H100. You just need to pick the correct size, correct quantization in order to fit it in and let it run.
Yeah, great. Thank you so much for that. Following on top of that, in terms of GMI Cloud, what are some unique advantages of using our platform for deploying and managing AI models compared to other platforms?
Yeah, that's also a very good question. Like I said, our solution is containerized, so it's really lightweight for user, but easy to spin up. And we have good performance support. For example, we use Ray-serve and we use VLM, and we also offer options like TensorRT, and you can even directly run Triton on our platform. So we have a lot of pre-built tools made it available, ready to use on our platform. You don't have to build all these wheels by yourself. You don't have to, for example, figuring out how I can make an inference server, how I can, for example, use the Triton inference server on our own cluster if you're using own cluster. Like, for example, how can I do the isolation, how the data storage would be. So you don't need to worry any of this when it comes to GMI Cloud. We already built that for you, and our platform is built to do fast inference using our GPUs. And also because we have a lot of data centers, like the first page I showed, you can actually deploy your workload in multiple regions. That will make it higher available as well.
Great. Yeah, thank you so much. There's one last question for you. And in terms of the future of GMI Cloud, what are some feature improvements or updates that we expect for deploying AI models on our platform?
When it comes to inference, speed is always the most important thing. So we will continue optimizing our inference library to offer the best cost efficiency. Also, we need to work. There are a lot of new models coming out every single day. So we're trying to customize our solutions to, for example, those of the famous ones like OpenSora and diffusion models. So I would say there will never be a day we've done all the work. It's always catching up to do because there are always new models in the AI domain. And once there's new model, there are new work for us to do in order to make it cost effective for our users.
Yeah, thank you so much. So I believe we lost Kurt just due to some technical issues. So we can save those questions for another time, or if you would like to reach out individually, connect with him on LinkedIn. His email will be attached to when we resend out this recording. But thank you so much, Shane and Eugene, just for sharing your insights, and for Eugene for that demo. I'm going to pass it over to Shane just to summarize some key takeaways from today's discussion.
I think today, if anyone was to walk away from this, it's really how important it is to have, you know, a GPU provider plus a highly performance storage provider partnering together for the end client when they're training models, whether it's fine tuning into inference and production. What we found again is that naturally the training process is complex, but being able to have either a platform that helps you orchestrate and manage the GPUs with connections in the foundational models like Eugene just showed, into the use case I talked about earlier with, you know, how easy it is with DDN to be able to add, increase your storage size at the data center, just means that you've got faster, you know, GPUs, faster time to market. And this will continue to be a partnership for us that will blossom down the road. And if anyone here, as mentioned in the follow-up, wants to reach GMI sales, you know, it's sales@gmicloud.ai. And then we'll also have a follow-up for DDN and Kurt coming as well too. But we appreciate everyone's time today. If you're watching the recording or you were here live, thank you again.
Thank you for that, Shane. Yeah, like he said, we will be posting the recording on our LinkedIn, Twitter, and YouTube platforms. So thank you all for attending today. And for more resources and just continued engagement, please visit our websites, follow us on social media, and stay tuned for future events as we will be announcing some in the next couple of months. Thank you all. Have a great rest of your day.
Thank you.